Hello, everyone, and welcome back to Black Harbor's Advanced TAR series. I'll let Justin take over. Justin?
Hello, everybody. Welcome back. So today we will be going over exercise 2.2. This is going to be talking now about the threat scenarios, feasibility, and risks associated with those damage scenarios that we had gone over in exercise 2.1. So we pulled out two of the exercises or damage scenarios from the past exercise here. You can see, so we have damage scenario of window is unable to be opened or closed. And one of the damage scenarios was able to be done via the asset of door ECU right. So what we're going to look at now is what relevant stride property or element this kind of aligns with. And then the threat scenario kind of talk about how somebody might actually accomplish that. And then any assumptions we might have about it. And then we will go into the actual kind of attack feasibility. How long would it take? What are the expertise required? What's the knowledge of the item, the opportunity window, and what equipment might somebody need? And then we would get a finalized sum and a risk. And from that, we would kind of know how important would it be to stop this attack from being a possibility, right? Like what further things might we need to do to lower this risk? So first thing here, we'll talk about the stride element. So we're talking about it being unable to be opened or closed, which if we look down here at the different stride threats, the denial of service is going to be what correlates to this the most, as it is stopping the ability of the feature to operate entirely. So you would just put denial of service here. And then the threat scenario, this could be almost anything that stops the service, right? We're looking at the door ECU. So here we could put something like CAN bus flooding. As this would effectively stop the ECU from being able to receive messages to tell it to open or close the actuator for the window, right? And assumptions for this, pretty much we're just saying that the CAN bus is able to be flooded. Like there's no safety measures put in place to kind of stop that currently. So elapsed time, if we go to the table over here, where's time at? Here we go, elapsed time. So it is 0 to 4, and we have week, month, 6 months, 3 years, or over 3 years, right? So less than a week, less than a month, more than a week, less than 6 months, more than 1 month. Let's see, how long might it take somebody to flood a CAN bus? This would be something like just plugging in pretty much any type of CAN tool, right? And just sending a whole bunch of messages as fast as you can with the most important tags on it, right? So this would be something that would be pretty easy to do and would not take long at all. There's no real investigation or trial or anything that would have to be done here. So this is likely something that can be done within under a week. So this would be a 0. I should just notice up here we have 1 to 0 or 1 to 4, but it's 0 to 4. And then expertise required. Same type of thing we were talking about a second ago there. It's going to be pretty much anybody could do this as long as you have some understanding of what's going on, right? So that's going to be more in the proficient realm, as somebody does need to at least understand CAN, right? It's not just popping a screwdriver in somewhere and everything works. So we're going to give that a EX1, or we're just going to do the 1 here, because we can see that it's under the expertise field. And then knowledge of the item. So what kind of information might they need to know about the vehicle or this feature to be able to do this? Is it simply flooding the CAN bus? Not a whole lot. They don't really need to know anything about the feature as long as they know that they can flood the CAN bus. So this would also be a 0, all just public information. And then here we have the equipment, right? So kind of goes back and forth between standardized or standard and specialized. in talking about, well, everybody has screwdrivers, but not everybody has like a can tool, right? Like this is specialized to some extent, but it's also pretty much the most basic vehicle communication tool out there. You're not getting like an oscilloscope. You're not trying to check the voltage. You're not doing anything crazy. So kind of back and forth on this one. It won't end up changing the feasibility at all. So it doesn't really matter. But let's just say since it's outside of the normal realm of just hand tools or non kind of computerized tools, let's just say that it is specialized in this case. So we'll give that a 1. And then if we look through here, knowledge of item should be 0. Put in the wrong one. Opportunity window. Get back at that one real quick. Window of opportunity. This is for a ECU that you're going to be connected to via CAN in some form or fashion. We're not assuming other things currently aside that it can be flooded. So let's assume that physical contact must be had. So you have to have access to the vehicle and access to the CAN bus or the OBDII port. So the window of opportunity is not going to be great. Where is that? There we go. So probably going to be moderate, as you will have to have physical access to the vehicle, but it will not be difficult or none, as you could possibly still get to this from the outside. So we'll give that a 2, which if you look here is actually going to be a 4, right? So if we do the quick math here, we got 0 for elapsed time, which if you look at the value of that, it's going to also be 0. Then expertise required is 1. So that's going to be a 3. Add that over here. Then opportunity window was at 2, which we just said ends up being a 4. And I got rid of the 3 for some reason. And then lastly, equipment of 1 is going to also be a 4. So if we add those up, we get 4, 8, and 11. So the overall sum is 11. Then we can get that over to the feasibility here. And then depending on what value you end up getting on this side, kind of shows you what kind of sort of value for feasibility you have. So at 11, we are under 14, but not 0, right? So we are going to be a medium. Or, no, it's greater than or equal to. So high, my bad. So we've got high here for the risk, and for the sum. All right. Yep, so we do have the feasibility here now, but we have to also now take into account the impact, right? So what is the impact of not being able to open or close a window? As you still have the ability to enter and egress from the vehicle regardless of a window being opened or closed. There's not really too much safety-wise going on there or anything like that. And you know that this is going to have a, at most, moderate impact, but likely negligible. So we can put negligible in here. And then we can look at a high feasibility with a negligible risk and bring that down here to the risk matrix. So we said the attack feasibility is high. However, the impact is negligible as there's not really too much going on there. It's not continuing through resistance, so not going to be breaking fingers. It's not going to be opening and closing just all the time. It's just doing literally nothing. So negligible and high, we get a risk matrix value of 1. So we can show that the risk is a 1. Now let's do the other example we have here. So this is going to be the other door ECU, but now instead of doing a denial of service, we are going to be doing a attack of spoofing, which we have here. Thread threats, spoofing, threat actor pretends to be something it's not. So we're going to be sending signals saying, hey, we are the other ECUs in the vehicle. Please open the window for us. And that would obviously be done by not the driver, right? And the threat scenario here is going to be spoofing CAN messages to the door ECU left. Get to open or close the window. So with this, when we get to the kind of impact area, we'll know ahead of time that we don't have a passing of other safety features. So we might be able to still close a window while somebody wants it to open and their arm might be out of it or something like that. But we aren't trying to bypass any type of safety feature that, again, would try and stop it before, breaking a finger or arm or whatever it may be, right? Or damaging somebody's property. It would stop before that. The assumption here, just for kind of the fun of this, let's say that CAN access can be achieved remotely. Just again, to make the whole damage scenario kind of just make more sense and examplable. Realistically, we would want, of course, no CAN access from anybody unless they're physically connected to the vehicle at the minimum, right? But things might happen. Let's just say for the sake of the example here that it can be accessed remotely. So maybe it takes a little bit of time to get into that remote access, and then you've got CAN communication with the vehicle. So again, looking here at elapsed time, we'll give this a 1 just because we're saying that maybe they had to do some like back-end work to connect to the vehicle remotely. And then expertise required. So since we are saying that they do again have to do some of that back-end stuff and also know some CAN things, we're going to say maybe they're an expert in the field in this case. So this is going to be a 2. Then knowledge of the item. They will have to know what messages are sent via CAN to either open or close the window or both, depending on what they want to do, right? So they do have to know those messages as well as any other type of counters or anything like that that are currently being sent for that message and kind of understand how to kind of reverse engineer that and send their own messages, right? So with that, we kind of know that the knowledge of the item has to at least be a kind of restricted access to it. So that would be a 1. And then the opportunity window. So again, this is going to be kind of how long of access do they have to the vehicle. Since we're saying this can be done remotely, and by that I mean like completely remotely, just via internet connection pretty much, this is going to be the highest or kind of lowest, whatever you want to think about it, as kind of window of opportunity here. It's going to be unlimited. They can get to it as long as they have internet. So 0 there. And then equipment is just going to be pretty much the same as before. You just need a computer or perhaps the CAN tool. So at most, we would say proficient here. So let's add up these values. Elapsed time of 1. That gives us a 1. And then a expertise required of 2 will give us a 6. And a knowledge of the item of 1 will give us, scrolling back here. Yep, knowledge of item 1, that would be 3. Then opportunity window is 0, so that'll be 0, and equipment is 1, so 0, and then equipment of 1 is a 4. So we add these up, we get a 1, 7, 10, 10, 14. So with that, our feasibility is going to be a medium rather than a high. And then we can kind of think of the possible damage scenario outcomes. So the window being able to be opened or closed by an unauthorized user. Perhaps this will cause some distracted driving on the highway, just from maybe, you're driving and this person's remote access window just starts opening and closing by itself. Might cause some confusion or distracted driving. We can't make that leap in kind of judgment and thought saying that it would lead to a crash or something, right? Because that kind of comes down to the driver and wouldn't really be a result of the feature necessarily. So we can't say that. Let's just say that the impact here would likely be probably around a 1 or a 2, as not too much can really happen. So we'll say that it is likely just a moderate impact again. So with that, again, down to this risk matrix, we can look at the moderate impact, and then the attack feasibility of medium means that this one has a risk of 2. So of course, in this case, the higher the risk, the worse, right? So a lot of times you'll find while running through Taras that there's going to be kind of damage scenarios that seem bad, and then you get to actually running through everything and it's either completely not feasible, or you think about it some more and the impact is actually a lot less than you thought. So regardless of how easy it would be to achieve the attack, there's nothing really that comes out of it for the hacker to actually gain, right? There wouldn't really be any safety impact or anything like that a hacker could gain from. So that does it for this exercise. Thank you, everybody, for joining in again. I look forward to talking to you again in the future.
Hey, thank you, Justin, and thank you, everyone. We'll see you next time.